Hi, I'm Nikita. I'm on the GLEE team for communications.
Hi, I'm Matt. I'm on the GLEE team for software.
And today we're going to be talking about the RF code. So, Matt, do you want to give us an overview?
Yeah, so we're going to have three different sketches for this module. We're going to have the RF transmit text sketch, the RF receive sketch, and the RF transmit temperature sketch. All of these can be found under File, Examples, GLEE 2023, Module Sketches, Module 9 RF.
Okay, so do you want to walk us through the RF transmit text?
Yeah, so the first sketch we are doing is the RF transmit text sketch, which can be found in the same place I said before, which is File, Examples, GLEE 2023, Module Sketches, Module 9 RF. Now, when you first open it up, you might notice that there are a lot of new lines of code that you may be unfamiliar with. This is okay. We're going to walk through everything to make sure that you understand what each line of code is doing so that you understand how we can transmit and receive messages with our LunaSats.
So, what does the radio library consist of?
So the GLEE radio library, like the other libraries we've been using, has necessary functionality, but in this case for our RF functionality. So here we want to include it. It's the GLEE radio library, and then we want to initialize a Luna radio object called RAD, which we will also be using later to represent our transceiver. So next you will see we have a variable called ID. You will want to set this to your team ID. If your team ID is just a single digit, you want to make sure you actually use 2 digits. So if your team number is 1, you want to use 01 instead. This variable will be important for distinguishing your transmissions from other teams' transmissions. Of course, if you are the only team working with LunaSats in your vicinity, this may not be critical, but you will want to make sure this value matches the values of other ID variables in the other sketches, which we will go over later. So our next variable is the string message variable. This will be the main content of your message. And then we have a full message variable, which is where we are appending our ID to our message. So next, we have 2 lines of code that you may be unfamiliar with, but that's okay. We'll go over each one by one. The first line is something that says char buff and then in brackets 40. So we have here a character array called buff, which stands for buffer. Basically, whenever we want to transmit messages with our LunaSat, we have to transmit them as a character array rather than a string. So eventually, our string will be transferred into this character array. The second line is something that says char star p equals ampersand buff and then in brackets 0. All this is that this is a pointer to the address of the first element of our character array. We will be using a function to send our messages, and we'll need the first address of our character array. So all we're doing here is actually getting that address and sending it to our variable p.
How would we set up the RF transmit text sketch?
So we will walk through what each line is doing one by one, but in general, we'll start up our serial communications. We will initialize our transceiver with some default parameters. We will convert our full message string into our character array, and then we will make our LED pin an output. So the first line is a line you should be very familiar with by now. It's our serial.begin function, which we are setting to 9600 bits per second so that we can communicate with our serial monitor. The next line of code is our initialize radio function, which we are using to initialize our radio object. Here we are passing 5 different parameters, which we are going to go over one by one. So our first parameter is frequency, which we are setting to be 915 megahertz. Frequency is basically a physical characteristic of electromagnetic waves. So here we are setting our frequency to be 915 megahertz, which does fall within the typical range for LoRa communications in the United States. Our next argument is our output power of our transceiver transmission, which we are setting to 17 decibel milliwatts. Next, we have bandwidth, which we are setting to 250 bits per second. Bandwidth is the frequency range of chirps used to transmit data. Next, we have our spreading factor, which dictates the number of chirps used to send a signal. Here we are simply setting it to 12. And finally, we have something called coding rate, which we are setting to 8. Coding rate affects our data encoding redundancies. So it is proportional to the tolerance of interference that our packets can handle. So essentially, the higher our coding rate value, the more our packets are able to handle interference that may disrupt or destroy our transmissions. So our next line of code in our sketch is us converting our string into a character array so that it can actually be transmitted from our Lunasat. So to do this, we are using the syntax string name followed by dot to char array, and then we are passing 2 arguments. The first argument is the character array that we are transferring our string into, which in this case is buff. And the second is the length of the array, which in this case should be the length of our message plus 1, just because that range is non-inclusive. And finally, we want to set our pin mode to output. So we are passing 2 arguments to pin mode, which are the pin number and the mode, and in this case, our LED and output.
So what loop should we be using for the sketch?
So our loop is going to be relatively simple for the sketch. The first line of code is us actually transmitting our data using the transmit data function. This takes 1 argument, which in this case is going to be the address of our character array, which you might remember is stored in the variable P. And then we want to blink our red LED just to kind of confirm to ourselves that we are transmitting. And then we want to delay by 3 seconds or 3000 milliseconds before sending a transmission again. Okay, so next we're going to switch gears and we're going to go over our RF receive sketch, which can be found in the same place as the previous sketch. You should note that we once again have a variable called ID, and you want to make sure the value of this variable is the same as it was in our transmit sketch. This will be used for team message filtering later on.
So what global variables should we be using for the RF receive sketch?
So before we do anything, we want to include necessary libraries and initialize our objects. So here we are including the GLEE radio library as usual, and we are also initializing a Luna radio object called RAD.
And what would the setup look like for this?
So the setup is going to look pretty similar to the setup of the previous sketch. We start off by setting up communications with our serial monitor using a 9600 bits per second argument. And then we want to initialize our radio object, again with the initialize radio function. And here we are passing the same arguments as we did before. Finally, we are setting our LED pin mode to output.
And how would we use loops in the RF receive sketch as opposed to the other one?
So in this loop function, our first line of code is us actually receiving any transmissions that the transceiver might have gotten. So here we are using the receive data string function, and we are storing the result of that function in our string called output. Next, we want to actually split the transmission that we received into the ID that was appended to it and the content of the actual message. So here we are using the substring functions. As you might see on the first line, the substring function takes 2 arguments, which in this case is a inclusive starting index and then a non-inclusive ending index. So in order to get the first 2 characters of our message, we want to use 0 and 2 as our arguments. However, if we want just the rest of the message, as we do to get the content, we can just pass the starting index of that substring, which in this case will be 3. Okay, and now we're going to actually do our conditional ID check. So here in our if statement, we have 2 conditions. The first is if the output exists, and the second is if the message ID that we received is the ID that we set in this sketch. So that's why it's important to make sure that your ID value is consistent amongst your sketches. So if those two conditions are true, we will actually print our message content and then blink the blue LED.
Switching out of RF receive, how would we code our RF transmit temperature sketch?
So our RF transmit temperature sketch can be found in the same place as the previous two sketches. And once again, we have an ID check. So you'll want to make sure that the ID variable has the same value as the ID in the other sketches. So as with previous sketches, we want to include necessary libraries and declare any objects that we need. So here we are including two libraries, the TMP117 library for temperature sensor functionality and the GLEE radio library for RF functionality. Then we have two objects. The first is a lunar radio object called rad, and the second is a TMP117 object called thermometer. Here we are passing two arguments to that object. First is the ID, which we are setting to 1, and second is the debug mode, which we are setting to true. So after we include our libraries and declare our objects, we want to initialize a bunch of variables that will come into play later in the sketch. Next, we want to do our setup function, which should look like the setup function for the previous sketch. We start serial communications with a 9600 baud rate. We initialize our radio object with the same arguments as we did before, and we set our pin mode to output.
And what would the main loop for this sketch consist of?
So our main loop here kind of combines the code from our basic temperature sketch with our RF transmit sketch. So here you'll see some familiar lines from previous modules. We are taking into account the time it takes to get our temperature measurements. So we are calling the millis function and setting that value to our start and end time variables. We are storing the temperature in Fahrenheit in our temperature F variable as well. And then we have another variable called temperature threshold, which is user defined. You are free to change it depending on your environment. All what's happening in this if statement is we are seeing if the temperature that we are reading is exceeding that user-defined threshold. If it does exceed that threshold, then we want to convert our data into a string, append our ID to that string, convert that string into a character array as we did before in the transmit sketch, and then we actually transmit that data to our other Lunasat before blinking our LED.